Today we're going to talk about how to build a full stack web app which summarizes archive LLM papers, every new paper, and puts their summary as a summary, bullet points, and keywords. You can go to the original article and read it more in detail. This does a search with using arxiv API for large language models and retrieves the newest ones and adds them to this website automatically. It updates every hour. This web app is live. You can visit it currently right now at llmpapers.up.railway.app. It is deployed at Railway. We will talk about the code and we will talk about how we can deploy it to Railway, a full stack app. It features this cool animation, as you see, on page load and on mouse hover. I'm not sure if I'll keep it in the future, but it's there for now. As you can see, you can click on it. It displays this modal. You can close it. You can also close it by clicking anywhere outside of that. It features infinite scroll, so not everything is loaded all at once. If you see the scroll bar, it's actually loading when it is appropriate. The most important feature is that it updates itself every hour if there is any new papers published on large language models. This web app is currently deployed at Railway along with my two other apps, echohive.live and the GPT-4 web UI. Railway apps makes it very easy to deploy apps. As you see, this is our logs. This is our task manager, which automatically checks every hour. You can also see some metrics of usage. As you see, the network traffic has been up because I just have been using it. So first, let's talk about how we can deploy to Railway, and then we'll review the code. This is a full stack app with index.html, main.js for JavaScript, the webapp.py, which uses FastAPi, and we do use app scheduler to actually schedule this task using actually the main.embed file, which actually does the heavy lifting for us. Now, the interesting thing is that I am not only retrieving the articles and actually saving the summaries, but I'm actually saving the vector embeddings for them as well into the CSV. As you can see, each summary and their vector embeddings are present so that we can actually do similarity search. You can do that with search.py. My original idea was to implement this online as well, but maybe I'll work on this, but currently it's not implemented. We'll talk about in detail about all these files here in a little bit after deployment. So one of the easiest ways you can deploy to Railway is actually just creating a GitHub repository. As you see, I already have done it right here. We already have saved articles, which consist of 100 articles to get us started. The rest of the articles will update automatically. We also have a summary.embeddings file, which actually updates the website. And we have a prog file, which simply tells how to Railway on how to run the app, which consists of how you would run it locally, right? You record your name of your file and the app, which you defined as FastAPi. Host has to be 0000 for Railway, and we just assign the port as $port so that Railway decides for us, and we just put this web colon thing in the beginning and save it to a prog file. That's it. Once we have all our necessary files, we go to Railway, we create an account. I already have one. I already have connected my GitHub, and then I click on New Project, and it's asking me, what do I want to do? I'm going to say deploy from GitHub repo, and then it actually, when you connect your GitHub, it lists all your repositories, and all you have to do is select the one you want to deploy, and that's it. Click Deploy Now. And it's going to work on building this. Now, while it is actually creating this, which takes about 2 or 3 minutes, depending on how many files you have and whatnot, you can actually go to your settings and scroll down to see this start command. See, this is the command that you would use to start. Obviously, you can specify the host and the port number when running locally. So if you didn't have the prog file, you could actually write the start command right here in the settings as well. But the prog file automatically takes care of it. Another way to deploy this would have been by going to Start a New Project and then searching for FastAPi. And when you click this, it will create a new repository in your GitHub with prog files and all of that already figured out, like configuration file. And then all you'd have to do is just copy and paste your files into this repository, and it would be ready to go. But I'll make another video about this down the line. The other two apps I've deployed on Railway is this GPT-4 web UI You can just simply, this is online, you can actually go there. I'll put the link in the description. You can enter your API key and you can talk to GPT-4. I use this when I run out of my 25 allowed GPT-4 usage with the ChatGPT UI. And another deployed app is the EcoHive, my main app, which is my EcoHive AI Academy, where you can search all my videos, find their descriptions, and actually find the code download links at Patreon. It's ecohive.live. Link will be in the description. You can use the search bar to search for anything. It's an instant search and also features infinite scroll. If you actually search for EcoHive and see this video, in this video I actually explain how I built this EcoHive app and deployed it on Railway. As you see, our application now has been deployed, and we can actually just simply click this auto-generated link. And this is online right now. I'm going to delete this app, but you can actually go to Railway, go to settings, and actually set a new domain name. You can actually edit this to whatever might be available, but it still have the extension of .up.railway.app. You can add your custom domain here very easily as well if you have one. So Railway is very easy. So we just deployed an app. As long as you have the app built, then you can deploy it so quickly. We can actually add a database to this as well. Railway takes care of all of that, but I'm going to make another separate video on this. Going forward, I will be creating this type of videos where rather than just hello world applications, we'll be building and reviewing full stack applications, how to deploy them with database, how to have user authentication, maybe how to connect Stripe as a payment system. Having said all this, all these code files will be available in my Patreon. We will go ahead and review the code, but like I said, all these files will be available at Patreon. The simple version of this file will be available for AI aficionado level, and then the full stack web app will be available at this $30 level. I appreciate your support. My Patreon comes with 100 plus project files for other projects that I've built. You can find their code files with your subscription as well. This is all I do all day. I like to learn and build new projects and share them with you. I hope you enjoy the journey along with me. Link to my Patreon will be in the description. If you do decide to become a patron and download the files, you can deploy them directly yourself, just as I'm showing you. If you have any questions, you can reach me at Discord or just make a comment under the video. The idea came to me after taking a glance at David Shapiro's Accelerating Science with AI, quickly read every paper. This video is really great. I'll put a link in the description. And the idea for the animation, this rolling random letters, came from Hyperplexed. If you're interested in learning about front-end design, this channel is great. I'll put the link in the description. It was this video, actually. Really beautiful stuff. Let's first talk about the web app files, and then later we'll talk about the search and the simpler version, the terminal version. This is our HTML. It's pretty simple. We are using some Google fonts and the tailwind's min.css reference from the CDN. This is probably not the best way to do it in production, but I've just gone with that. This is just a favicon, which is present here in the directory as a ICO file. This is the little icon that displays next to the title of the website. And here we set up some divs, for example, our title and some of the links that I have to my Patreon and ecohive.live and the flashing animation that you see happening here for updated every hour. So we have an article container, but we are actually populating the article container using JavaScript. So we're going to talk about that. And we have a modal right here, which we also manipulate using JavaScript, which allows us to, when we click, display the pop-up with the full summarization. Okay. There's so much code to talk about, so I'm actually going to just briefly mention everything. Like I said, the code files will be available at Patreon. Do let me know in the comments if you like more detailed code review videos as well, maybe your live coding sessions. With JavaScript, we are actually getting all our elements from the DOM, from the HTML. As you can see, like the article container and the modal and whatnot. We set some variables here. And this first function actually loads the first 8 articles on page. I believe I've actually changed it because it happens right here on our webapp.py file on the FastAPI side. It's actually 16. That's fine. Actually, I can change that to 16. That's just a comment. It essentially on load, we're saying we have an event listener. On the page load, we do fetch articles, which we're going to talk about. We have that function right here, which just receives, it makes a fetch request to this root on the FastAPI side, and then just receives the data. And right here, we are actually returning paginated articles. The second function actually deals with infinite scroll. We say as the user approaches to 500 pixels to the end of the page, then we initiate infinite scroll. As you see the page, as we approach, then we load new articles. We fetch them from the backend. So not all articles are loaded immediately, obviously. The next part is the animation of the title, which animates the title and page load, and also on hover. This is what I learned from Hyperplexed. Link will be in the description. So we just have the entire alphabet, and then we loop over them, and then we select a random number each time for each iteration, 30 times a second, except when each iteration occurs, we actually put back the original letter one by one. That's why we get this cool effect. Next is to hide the modal, and then the fetch articles. This is obviously connected to the articles endpoint right here, which receives the articles from here, which receives the articles from the Python backend, which utilizes load articles from CSV function. We're just going to talk about this here in a moment. And then we have the search articles, but I'm not utilizing it. And then we are appending and adding all the articles to HTML. And then we have the open modal and some event listeners to actually close the modal, both with a button click and also from a click to the outside of the modal. The Python backend runs with FastAPI. This is all our imports. We are using the app scheduler. This is a requirements, right? The requirements.txt file will be available at Patreon as well. We are also importing the main_embed, which is our main file, which does the heavy lifting. But we'll actually talk about that right after this. We have this function here. We are defining our app as FastAPI. That is why in our run command, start command, we need unicorn to start the server, and then this is the file name, webapp.py, and then app is what we've specified as our FastAPI, which is specified right here on line 8. Then we have this load article from CSV function, which just loads the articles as ID, title, summary, URL, and the full summary. This is the get articles by ID. Now the next part is the cool part, I think. So we are initiating this my task function. We do enter the large language models. I am entering the end so that it will actually search for multi-word search with the archive API. And we are searching for 50 articles. We are updating every hour. We'll never probably have 50 articles published within 1 hour, but just to be safe, we have our saved directory as the saved articles. And then we are using the main function from the main._embed file, which actually retrieves all the articles, summarizes them using GPT 3.5, and actually gets all the embeddings and saves them to the summary embeddings. We're going to talk about this here in a moment. So this is our task, right? We want to run this every hour, but on event startup, we actually define the startup event function, which these are all async functions. We do print task engine started, and then we run this my task immediately, just to make sure that we are up to date with all our papers. Then we assign a background scheduler, and the scheduler is going to run every hour. Maybe I'll demo it here in a moment, and we're setting this to 10 seconds to see, and then we start that scheduler. So this way, this function will run and call this entire file and run the main function, which then will retrieve all the articles, summarize it, and add it to the summary embeddings.csv so that they can be reflected on the page, on the main page, since these are all populated from the CSV file. And then we have our articles endpoint and articles ID endpoint, and we are mounting the static files from the static folder, which HTML set to true. So our index and main.js is under the static folder. Our main backend is on the working directory. Now I would start this by saying unicorn webapp equals app, because webapp is the name of our backend. And then app is what we've defined as the FastAPI, and then -- reload. I'm not entering any particular host or port or anything like that. So this is live at this location, but look what happened. We said task engine started. So on the app load, we actually started the my task. We said print task engine started. We ran the tasks. We checked 50 articles from archive. They're all saved. Paper retrieval task completed. And then now actually our web app is live. If we click, we are running locally on port 8000 on host this IP address. And as you see, we can actually check everything is working fine locally. So anyway, that was just to demonstrate. Let's now talk about this, what main_embed file is doing. Like I said, all these files will be available at my Patreon. The main file, search or similarity search, and main_embed will be available at the $9 level, and the rest of the full stack web app will be available at $30 level. Link will be in the description. Also, if you enjoy my content, please subscribe to my channel so that you can see our future web app videos, and feel free to visit ecolive.live to see all the other videos that I have created. Okay, now let's take a look at main_embed. We are actually importing archive for API. We are having requests, PyPDF, because we're going to retrieve the URLs from archive API. Archive API doesn't deliver the full text of the papers, but it provides the PDF URLs. So we're going to actually retrieve the URLs and download them, and then extract the text using PyPDF. So we're using requests to download. We are getting archive for the paper information, including the URL. We are using requests to download the PDF, and we are extracting the text with PyPDF. We are using tick token to do token counting, OpenAI pandas for data frame, and I'm just using cosine similarity from scikit-learn. Not sure if that makes a big difference, but you can use the one from OpenAI as well. Here I am defining my API key from my environment variables. Here's the count token function with tick token. It just accepts some text and returns the token count. Sanitize file name, that is just to make sure that we don't run into errors while saving the file. This is just creating the directory function. This is the download article PDF. So this receives the URL, which we are going to get from archive. Then actually extracts the text to PDF. Then we go page by page and returns the text. Sanitize article text actually looks at the references. So actually, let me talk about this real quick. You're on archive and click any one of these articles and load them. And if you scroll towards the bottom, you'll see this references, which is quite long and it's not, and then there's some additional information, which is probably not very relevant, or it is relevant, but not essential. So I'm trying to actually remove everything that comes after the references. And I am doing that with the sanitize article. And then this is just to save the article. Now summarize our article, it should count number of tokens, counts the tokens. And we do want to limit. So when you actually run this, usually articles are below this 15,000 tokens, especially once you remove all the references. But just in case, if they are not, I'm just cutting them off to 15,000 tokens. Okay, I'm just keeping the first 15,000. And we're making a call to 3.5 turbo 16K. We are actually using streaming responses, and the mixed tokens is 1,000. Here I have my system prompt and return a summary. And we actually print the streaming responses and also return the entire responses. I made other videos on talking about how you can do streaming responses. Then I have the get embedding. This is to return embeddings for the summary or any kind of text you give it. This is actually a function to do similarity search. I'm not really using it here. I have another file for that. And this is our main function. Actually creates the directory and then it sets the directory where it retrieves all the files from the saved articles. Okay, all the names of the files from the saved articles. This includes, eventually end up including both the paper itself and the summary of it. This is probably not the best way to do this, but I went ahead and did it this way anyway, so that I can actually have all the articles saved as well. Then we're doing a search to archive search with our keyword, which is large and language and model. We're returning and many results, and then we are sorting it by submit date. Then we're creating a pandas data frame. Then this is just to initialize the data frame. We check if summary embeddings exist, CSV file. Then we initialize that as the old data frame using pandas. And then we initialize a new data frame with title, summary, URL, and embedding. Then we enumerate over the results. And then we sanitize the file name, and we check if that file name exists in our current file name. Then we actually skip that since we're going to be doing this check every hour. And then we download the article. We're using the above function. We print the token count. We sanitize the article. We print the token count after sanitization, meaning after the removal of the references. And we get a save path for that particular file, including its file name. We save that article. We get the summary using the GPT call. We get the embeddings, and then we append it to our new data frame. Okay, with title, summary, URL, and embeddings. And then we print the summary just for information purposes. We get the summary file name and the save path, and then we save the article. And then we combine the old data frame with the new data frame by concatenating them, and then we're saving them to summary embedding so that we can continually update the CSV with new. And then we just simply run it originally for 100, because this will only run if you run this file, okay, not when you import it. Originally, I've just saved 100 to get us started with the web app. But when this file is imported to our web app, actually, as you see, we are importing main.embed, and we are using it in under my task function. We are actually setting n to 50. We are retrieving 50, okay, with the keyword large language models with end in between each word. Save directories, saved articles. And we have this main.py file, which does everything we do, but simply if you have the count tokens function, sanitize file name, create directory, download article, sanitize, save, and summarize. And then we have the main, which actually prints it and saves it to a directory, but this doesn't do any CSV manipulations. So we can actually run this real quick. Whatever we can set n to, let's say, just 3. And then if I run this, I have changed the save article underscore copy. So we won't actually affect this already saved files. It will actually create a saved articles files itself. So I'm just going to run it real quick to see what's actually happening. Okay. As you see, it created the saved articles folder. Number of tokens in paper was 22,000. After we remove references, it's 10,000. Summary of article 1 is like this. Then it's saved right here. Under saved articles is the full text and the summary. And now the second paper was 23,000 tokens. After removing references, it was 14,000. I believe we're not doing any embedding operations here either in the simpler file. This will be available at Patreon as well. And now the third one, which was 18,000 tokens. And after a sanitization, 10,000. Anyway, so now we're done. As you see, we have all 3 files with the original text and their summary. And we haven't affected our original CSV because this one doesn't do any manipulations of the CSV. I'm just going to delete this and restore our original saved articles, which is what we are using. Now, the cool part is you can actually do a similarity search. Let's actually try. We are doing similarity search using the summary embeddings.csv. This is to show that you don't need anything fancy to create embeddings or embedding search engine. A simple CSV file would suffice. Probably not the best approach. But if you run this, okay, and search for something, it is going to convert our query into embeddings, and then it will actually do a similarity search. This one actually uses NumPy. The one and the main underscore embed file actually does use scikit-learn. Anyway, we can enter a query, for example, large context window, and it'll actually bring up the most similar article. See, contrastive learning extends effective context length. So this is probably not the best similarity search. This is just, look at all these as experimental stuff which you can use. This one uses NumPy. As you see, it does do some dot products to find the similarities. We're only returning the top result. But if you take a look at the main underscore embed, the search function here actually uses the cosine similarity from scikit-learn. Okay, so there's many options to do all of this, including saving them to a simple CSV file. This is a really long video, but I think it was worth it. I hope you really enjoyed it. I'm at Railway again. Remember the app that we started? We can see that it's actually online still. This is the app that we had deployed in the beginning of the video. I'm actually going to go ahead and delete it so you can see how to delete your apps as well. Railway is great. You can start apps, delete apps as many times as you like. I'm going to go to settings and go to danger. And here it says delete project. You have to copy and paste this to confirm. Do not delete anything you don't want to delete. And then I do have to enter my authentication. Once I do, that has been deleted. Your project has been deleted, but the rest of my projects are up and running. Like I said, the rest of the projects are actually arxiv AI Academy. You can search all my videos here and find the ones that are relevant to you, find the code download links. There's also links to the autocoder. This was a project I worked on a few months ago. It's a really cool app. Almost 12,000 people have used it. Check it out yourselves if you like. And there's the GPT-4 web UI, which you can use to actually interact with GPT-4. This only works with GPT-4. A link to these will be in the description, along with articles, which is llmpapers.app.railway.app. I hope you enjoy this. I will be talking more about full web apps and how to build them, how to deploy them. I'll make the code available at my Patreon, unless I'm actually turning the code commercial myself. Let me know what you think, and hopefully see you in the next video. Take care.